So here we go. Now it seems like, wow, we're in chapter 6. Every chapter that we've done things in, we've always had a moment where we had to solve equations, okay? We did that for solving quadratics. We solved absolute value equations. We've solved linear equations, so all kinds of equations. Today we are going to solve radical equations. They're not that bad. Are you pretty good at solving equations by now? Oh, okay. Solve radical equations. And there are two kinds that we're going to do, so A and B. So let's start with the ones that have the radical symbol. Okay, just a reminder, in your homework, and I'm talking to some of you for sure, in your homework, when you do these, you are going to, number 1, write the equation that you need to solve down. Okay? Most time I don't make you write the problem down that you're doing, but with equations I do. You write the equation down. Number 2, you show work. If you do not show any work, I will hand it back and give you a 0. Okay? Some of them I understand you can do them in your head. They're easy. Most of them you cannot. Yeah? No? Not only do you show work, but you show work in a column format. Okay? No, people need to know this. I know this is silly. Column. Okay. So like if you had something like 2x plus 3 equals 9. Okay. And let's say you're in Algebra 1, you're learning how to solve equations. You have to show work going down the page in a column. Yeah. So 2x equals 6, and then you divide by 2, x equals 3. And then you put a little box around your, that's what I want to see. Okay? I'll have people who will solve this, and they'll go like this. 2x plus 3 equals 9. And then they'll write next to it, 2x equals 6. And they go that way. You're not supposed to solve equations that way. You're supposed to solve them going down your page. I know, it just doesn't even feel right. I could barely even do it. No, you know what you do? You split it in half, and you do those. No, then you're doing exactly what you need. Okay, and then finally, number 3. Put a box around your answer. Okay? So that's what I require for your homework. You write the equation down, you show work going down the page, and then you box your answer. All right, so let's do some. Now, in order to solve radicals, what you want to do is you want to isolate. Do you know what isolate means?
Get it by itself.
Get it by itself. You want to isolate the radical. That's your first step, okay, to get the radical all by itself. And then after that, you are then going to square both sides. So step 1 is to isolate the radical and then square or cube depending on what root it is, both sides. Okay? All right. We'll start with some easier ones, and we'll get to more difficult. Here we go, number 1. And if you want to, you can split your paper down the middle and do these, but either way. 2 plus the square root of 3x minus 2 is equal to 6. All right, so it's almost like Christmas in here. We just were given this present, and now we have to unwrap it and find out what it is. Isn't that exciting? It is. So when you wrap a present, you start by putting the present down, you put the stuff on, you do the bow, and you put a card. When you unwrap, you got to do the opposite. You always have to read the card first, right? I know you don't want to. I never did. And then you take the bow off and then the present. So that's what we're going to do. We're going to do opposite order of operations. So our first step is to subtract 2 to the other side. So I'm going to subtract 2 to the other side. I'm showing my work like a good child. And I get the square root of 3x minus 2 equals 4. All right, so far so good? Yes. Now, do you see that radical? We've isolated it. It's the only thing on that side. I got rid of anything else around it. That was just the 2. Brought it over. So now I got to get rid of a square root. Well, what's the opposite of a square root? Squaring. So I'm going to square both sides. Right? When you square a square root, they cancel each other out. So you're trying to unlock that 3x minus 2. And I've unlocked it out of that radical. 3x minus 2 equals 16.
So you're pretty much just taking out what's inside the radical.
Yes, well, you have to square both sides. Remember, whatever you do to one side of the equation, you have to do to the other.
Yeah, well, when you go like to the next line down.
Yes, you do. The square root and the squared cancel each other out because they're inverse functions. It's gone. And now the rest is just simple algebra. And I don't really think that you need to so much show work here, you know. You can do the rest in your head, right? Add 2, what do you get? 18? 6. X equals 6. Put a box around it. You can even be a little extra and check your work. You don't have to. Austin says no. Maybe on a quiz or test, you want to make sure you got it right? Okay. You would plug 6 back in to your original. See the one in black? 6 times 3 is 18 minus 2. Square root of 16. 4 plus 2, 6. All right. That was a good one. Let's do another one. Number 2. 2, rad. Bailey, you ready?
Yep.
Perfect. 5x plus 1 minus 12 equals 0. Okay. I'll do this one in green just for fun. All right, so here it is. And we want to, first step is to isolate the radical. So see that square root right there? We got to get it by itself. So our first step is to add 12 to the other side. Your first step is to add or subtract anything, if possible. You add that over. And you end up with 2 square root 5x plus 1 equals 12.
So 2 is part of the radical?
2 is in front of it. So now we can divide by 2. So 2 is being multiplied to the radical.
Okay.
It's like if you had a 2x equals 10, you would divide by 2 to solve. So now that's what we're going to do. We're going to divide both sides by 2. So over here, the 2's reduce, leaving me with rad 5x plus 1. And over here, this is 6. All right, so we did our first step was to isolate the radical. And this is a square root, so how do you get rid of a square root? You square it. You square both sides. It's the golden rule of algebra. Do unto one side as you do unto the other. It's true. Just have a poster in here that said that.
You just turned this into biblical.
Biblical, yep. Mathematics is very biblical. 5x plus 1. My devotions this morning was all about statistics and biblical principles. All right. 36. Okay, and then from there you can do it, right? You're pretty good. Subtract 1. 35. Divided by 5, x is 7. Put a box around it. Check your answer if you feel so needed, but we know we're doing these right, so we're not going to.
Yep.
Okay, now, ew, gross. You're going to try one. You're ready.
Yeah, I always do them the first day, and then you're like, oh, but now they're...
And they get harder. Yeah. This is kind of Algebra 1-y right now, but...
confident going into it.
No, you are confident.
And then you...
No, and then I kill it. Not me. I don't kill it.
It's the test. I take one
Mm.
and I do everything right on my homework.
And then the tests kill it. Well, the tests, yeah, they have a lot in them, huh?
Quizzes too.
Yep. All right, so try this one. Negative 10 plus rad 2x plus 1 equals negative 5. So write it down. Here we go. Add 10 to the other side. Let's do this one in yellow. 5. Good. Square root 2x plus 1 equals 5. Okay. Isolate the radical. Now, square both sides. Yes. Square and square. 2x plus 1 is 25. And then, yeah, if you can do this part in your head, be my guest. Subtract 1 is 24. Divided by 2 is 12. How many people got 12 on that one? 1, 2, 3. Note to the video, about 20 of them did. That's really good. Okay. What, the video, they can't see how many hands were raised. Letter B. All right, so those are radicals. I think you're going to do just fine. That's really as hard as they get. Okay. No, I'm not. There might be a couple tricky ones. Uh-huh. Rational expressions. Or rational exponents. Sorry. Rational exponents, not expressions. You do? Oh, you don't? You like irrational better? Rational exponents. And we're back. All right, now, what you're going to do with rational exponents is in order to solve, you are going to do this. You're going to raise both sides to the reciprocal. Do you know what reciprocal means? A little refresher? Reciprocal, yeah. Okay, so like for example, if I have something like this, x to the, let's go with 3/2 is equal to 27. This is hard to solve. Like, can you do that in your head? Like, what number to the 3/2 gives me 27? That would be tough to do. This is what you want to do. You want to raise both sides to the reciprocal, 2/3. Reciprocal, remember, is to take the fraction and just flip it. So we would raise both sides to the 2/3. Now, what does that do over here? It does. It's just x, you're right. And then over here, this is the stuff that we did last week. Do you remember how to take the cube root of 27 and then square it? Not almost. Cube root of 27 is 3. 3 squared is 9. For those of you who don't like to do that in your head, it's too much. It's like 2 steps. 27 to the 2/3 is 9.
Oh, so you did that in my head.
You're not timesing both sides. Thank you. Yeah. Oh, you're raising it to the power. Yes. You're raising them to the power.
Wait, how you done that in my head?
Yeah. So you go 27. Do that caret symbol to the 2 divided by 3. Should give you 9.
What the heck?
I could have done that in my head.
I told you that last week. Okay, so let's do some. Number 4. Sorry, I wasted our time. We only have 3 more to go. Here we go. 2. X plus 2 to the 3/2 equals, I don't like the one I have. Hold on. 128. Okay. No. All right, good question, though. No, you're not allowed to distribute into here because this is to the 3/2 and you can't bring that in. What you can do is you can divide both sides by 2. So your first step is to, just like the radicals, we're going to isolate this power part. So if there's anything around it, we want to get rid of it. So bring it over to the other side. So that you get x plus 2 to the 3/2 equals 64. Okay, now we want to get rid of that. We're trying to solve for x. We got to get rid of this 3/2 to the 3/2. And the only way to do that is to raise both sides to the 2/3, the reciprocal. Okay, don't forget it's the reciprocal. A lot of people will just raise both sides to the 3/2 again. Well, if you're raising something that's already to the 3/2, you're not getting rid of it. If you raise this to the 3/2, see how the 2's reduce and the 3's reduce? What's 3/2 times 2/3? It's 1. 6/6, which is 1. So you end up with x plus 2 over here. And now this part, feel free to use your calculator there. 64 to the 2/3. Did you use your calculator?
Yes.
How many of you guys can do those in your head? Cube root of 64 is 4. 4 squared is 16. Last step, x is 14. Ooh, that's Greg's hockey number. Okay, number 5. Greg? No, it's not. All right. 3 times x plus 1 to the 3/5 equals 24. Do you want to try this one?
Yeah.
Oh my goodness. That makes me so proud.
Wait, what is that?
Equals 24. X plus 1.
I thought you were going to do this as XH or something.
There we go. Is that better? I like pink socks. Divide 3 on both sides. Perfect. So start by dividing both sides by 3. Isolate the radical, isolate the power, isolate all those parts by getting rid of anything you can. Now raise both sides, yep, to the 5/3, to the reciprocal. Don't forget reciprocal. Perfect. X plus 1 equals 32. You're doing those on your calculator. It's great. Cube root of 8 is 2. 2 to the 5th is 32. So X is 31. Who got 31?
Oh, yeah, bro, I got that.
Good. Lots of them did. Okay. Last one. Last problem. It's only been 15 minutes of notes. Yeah. You shouldn't have asked me about my kids, man. I'll just go on and on. Okay. You're like, I'm sorry. Sorry, I asked. It is. It's the last one. Okay, this one's tricky, though. Okay? 2 times x minus 2 to the 2/3 equals 50. Now, this looks like a regular problem, but it's actually a little bit more than regular. Okay? It's a little different. Yeah, I'm going to show you why. Do what you normally do. Divide by 2. You get x minus 2 to the 2/3 equals 25. Okay? Nothing's changed. Raise both sides to the 3/2, and then let's talk. Okay. What happens here is, we haven't had one like this. See this root? What happens when you take the square root of both sides of an equation? Do you remember? You have to do plus or minus. When I give you something like x squared equals 16, and you take the square root of both sides, you get plus or minus 4. 2 answers. So anytime you're taking the square root of both sides, the other ones were odd on the bottom. There's a cube root, right? Were they both cube roots? Yeah. So this is a square root. This is going to change things, okay? So over here, we still have x minus 2. But over here, you have to give me 2 answers instead of 1. So if you do that on your calculator and you do 25 to the 3/2, it will give you 1 answer, but you need both of them. So what did it give you? 125? 125. But you need plus and minus 125. Why? In just a minute. Okay. The reason why is because, see this x whatever, it's being squared. And so you can have a plus or a minus, because when you square a negative, it becomes positive. So you get 2 answers. We're square rooting both sides at this step. And when you square root both sides, you have to do plus or minus in an equation. All right, so we really have 2 equations. We have x minus 2 is 125, and x minus 2 is negative 125. So x is 127. Add that, and you get x is negative 123. So you get 2 answers here. They both work, but that's the only time you will get 2 answers. Okay? It's because it's squared in the original, and because when you take the 3/2 to the both sides, you're taking the square root of both sides, which you have to do plus minus. So